Hello and good day. My name is Abigail Hwong. I am from class CEEE2233A. This is a video for lab 1, and the objective of this lab is for me to be able to write simple assembly language programs for the ARM microcontroller using data transfer and data processing instructions and addressing modes. The next objective is for me to execute the programs using an ARM key editor, assembler, or simulator. Now for question 1, student is required to store 0x30 into R0, 0xABCD into R1, 0x1295A F90 into R3, and copy R1 into R9, R3 into R10, R0 into R11. So now let us build this program. Zero error, and we can debug. So for question 1, here we can see there R0 has 0x30 has been stored into R0. I am using move because move can store data which has 1 byte, which is 0x30 has only 1 byte of information. Now for the next one, 0xABCD, I use move W because move W can store a half word data size, which is 4 times 16-bit. And for the next one, 0x129F925AF90, I use LDR here. The data has been entered. It has been stored into R3. I use LDR because it can contain 32-bit size. All of this addressing mode is I am using type immediate addressing, immediate offset. Now R1 should be copied into R9. There, R1 is the same as R9. Now R3 into R10. Yes. See, now value of R3 is in R10, correct, and R0 is in R11. This type of addressing mode is using register addressing. That is all for question 1. Now for question 2, students is required to store data 0x2233 into memory location 0x40040000, and then copy value of memory from 0x40040001 until 0x40040004 into R0, and then student is required to copy value from memory location 0x40040000 into R1. So now we build this program. There is 0 error. Now we can debug. Again, in this is the same thing as in question 1. I use LDR because I am required to store an 8-byte size of value into the register. This is using immediate addressing mode. So now we should run over the lines until value of 0x4004,000 is into R7. There, the memory has been stored in R7. I'm sorry. And now we have R2 and R3. Now I use storage, which is indirect addressing immediate offset. Value R7 should be put into memory location of R3. See, we can see the changes here. 0x2233 has been stored into 0x4004,000. And the next one, by line 10, memory here, R4 has been entered into memory location of R2. And this is it. And now I have copied value from 0x4001 until 0x4004,000 into R10. R0. See the changes there? This is 0x4001 until 020304 has been entered into R0. And for the next line, which is LDRB, I am to copy the value in memory location 0x4004,000 into R1. Our value here in R1 should be 0x33. This part I am using in indirect addressing immediate offset. That is all for question 2. So this is question 3. Student is required to add 3 values and store them in R7. So the 3 values are 0x20FE5690, 0xFE123089, and 0x3458970. In this question, I will be using data processing instruction because they told us to add. The question asked the student to add, so I will be using add. So now we can rebuild. There is 0 error, and then we can debug. So we run over the lines until we can see 0x20FE5690 enters R0. There, the value has entered R0. We should expand this because we want to see the changes in the CPSR. And 0xFE123089 has been put into register R1, and it has been put into register R2. So now we have to add R0 and R1 first. We should get value of 1F10, yes, at 719. It has been put into R7. Then we have to add another value because we need to add all the 3 values into R7. So we add R7 plus R2 and store them again in R7. So now we can see there is still no changes in CPSR because this means that there is no carry. So now after we add the value of these two into this, you can see the new value is the end value of all the three numbers is 0x53691E29, and still there is no changes in CPSR because there is no carry, and Z also remains 0 because the value is not 0. So that is the end for question 3. So now we are back on question 4. Question 4 is required that the student write a program that will store 0x2936FEDA in R8 and then perform the following instructions on the content of that register 3 times. Before executing the program, we should set the initial value of C flag equal to 1. So now we put the data 0x2936FEDA into R8 using LDR because of the data size, which is 32-bit. Now we can build. There is 0 error, and now we can debug. Should expand the CPSR because we would like to set the initial value later. So now we run over the lines until 0x2936FEDA is stored into R8. There, the value is stored in R8. So now we set the value C equal to 1. And now we run over the lines. ASR will not affect the carry. See, we can see that the value of C is still equal to 1. But after shifting right the value of R8, we can see that the value has been changed into 0x0526DFDB. So now we step another to line 7. Now we can see that the value C has been, the carry flag has been changed to 0 because the MSB of the data is pushed into the carry, which is 0. Now the data has changed into 0x2936FED8. All of this can be seen if we run through it manually by using binary. And now when we run to line 8, we will rotate right the data. So now the value C still remains 0, and we have rotate right the value, and it is now 0x0526DFDB. The initial value of C has been changed to 0. That is all for question 4. So now back on question 5. Student is required to write a program that will perform logical OR on 0x6398 with 0x1DFE. And next, the program performs logical XOR on data 0xA1B34690 with 0x13894B5C. We should execute the program. This is the program that has been written. We should put the value into, I have put the value into R0 and R1 by using move W because they are a half width data size. And now we build the program. There is 0 error, and now we can debug. We should run over the lines until there is the value 0x6398 is entered R0 as usual. There the value has entered R0, and now 0x1DFE should enter R1. So now we use logical OR on R0 and R1, and it has to be stored into R5. The value we should get is 7FFE. Yes, it's there. So now we should use addressing mode LDR, which is immediate addressing, immediate offset, into R2 and R3 for both data, and then we XOR the value in R2 and R3, and they should be stored into R6. We run over the lines to see that the value R2 has been changed into A1B34690, and R3 there, and then we should see changes in R6. We should get B23A 0D-CC. Yes, we have got the answer. So for question 5, the reason for this is because OR changes the binary value. If we do it manually in binary value, we can see the changes, and for XOR, which is exclusive OR, we will see, if we do it in binary manually, we can see the changes visibly. That is all for question 5. So in conclusion, the students have been able to recognize which addressing mode which should be used with a different data size, and understand the data processing instruction, which I have used in these questions for the lab at ASR, LSLS, RORS, and I have used properly the data transfer instruction. And I can now understand how to write simple assembly language programs using ARMQ editor. Thank you. That is all for my lab 1.